Okay, this is the 2008 FRQ number 1 in the calculator portion. So a graphing calculator is required for this part of the question. It says find the area of R. Since R is the region bounded by y equals sine of pi x and y equals x cubed minus 4x, the top function here is ry equals sine of pi x. The bottom function here is y equals x cubed minus 4x. If we're looking for the area of R, you can see that it is bounded at 0, 0 and 2, 0. So our integral can be set from 0 to 2. So for part A, the area of R is 0 to 2, top function sine of pi x minus the bottom function x cubed minus 4x dx. If you don't want so many parentheses around your equation, you can go ahead and distribute the negative, and so that if you, when you are putting this into your calculator using Math 9, you don't have to put in so many parentheses. So I would strongly recommend go ahead and change this to sine of pi x minus x cubed plus 4x when you plug it in. All right, so I'm going to use Math 9, and hopefully, yes, you can see. My function is sine of pi x minus x cubed plus 4x. Double check everything's correct. Comma x, comma from 0 to 2. Before I press enter, double check my mode. My mode should be in radians. All right, perfect. And now when I press enter, it says 4. My answer is 4. It's actually a really beautiful answer. Shocking, yes. All right, so the area is 4. This particular problem, you actually don't necessarily need a graphing calculator to do. You can actually do antiderivative and check, which is what I did in my notebook. But the calculator and my work show the same answer. The answer is 4. Okay. Part B then requires a little bit more imagination. The horizontal line y equals -2, so it's right here, y equals -2. Splits the region into 2 parts. Yes, splits are into top and bottom. Write but not evaluate an integral expression for the area of the part R that is below this horizontal line. So now my region becomes this horizontal line and this curve right here. The top function is y equals -2. The bottom function is now still y equals x cubed minus 4x. Here's the problem. Where do they intersect? Where does my integral start and where does it end? So we need to use our calculator to help us figure out where do those two functions intersect. So going back to my equation, I already have y equals x cubed minus 4x in there. I'm going to put y equals -2. And in order for me to see the picture better and not have to run around with my window, I would use the window given to me here. And so use that as a little guideline. Go to window, x minimum, -1 to 2.5, a little bit more than that. And then my y minimum, -3, so -3.5. And it looks like a little bit above 1, so 1.5. And I press graph. There we go. So this is the picture I want. We didn't graph the first one. We didn't graph the sine equals pi x, so we wouldn't have this curve, and that's okay. We need this and this intersection. So using second calc, intersect. Let's go to the very first intersection point. Press enter, enter, enter. And we will see that the first intersection point is at 0.5918887. Again, the more decimals you keep, the more accuracy you're going to have, but it's not going to matter too much here because it says just to write your integral, so you don't have to evaluate this. So my first point is x equals 5392. All right. And then the second intersection point, I have to do this whole thing all over again. Second calc, intersect. Now I'm going to the second intersection point, moving over as quickly as I can. Enter, enter, enter. My second intersection point is at 1.6751. Okay, so my integral is now going to be the area is equal to integral 0.5392 to 1.6751, top function of -2 minus x cubed minus 4x dx. All right, and it says write but not evaluate, so that's it. That's the answer for part B. Okay, next, part C. The region R is the base of the solid. This is a cross-section problem. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. So again, the trick to seeing this picture is to go ahead and put your x-axis like so, and your y-axis a little bit curved like that. So your graph, your region is like that, and this is the bottom. So this is the really weird piece up there, but now it's three-dimensional. And so anything that is perpendicular to the x-axis, or perpendicular to the x-axis, we're gonna have a square. So this is what we're looking at. I'm gonna build lots and lots and lots of little squares, right? Lots and lots of little squares. So that's the idea of it, all right? So the top and bottom function is going to restrict one side of my square. So each side is gonna be the top function, sine of pi x, minus the bottom function, x cubed minus 4x, right? Each piece is a square, so area of a square is psi squared. So how to calculate this cross-section will be the integral. So the volume is equal to the integral of this side, sine of pi x minus x cubed plus 4x, the whole thing squared. Oops, I have an extra parentheses here. Don't need that one. All right. And dx, from where to where? The region has it bounded from 0 to 2, right? So we're going to go from 0 to 2 again. Now, you can go ahead and put this in the calculator again. I think what we had before didn't have the square, so it's going to require a little bit more parentheses again. So let's go to math 9. Let's see. I think it's a better setup this way. Yep. Okay, so let's go math 9, parentheses. Now my equation, sine of pi x, close parentheses, minus x cubed plus 4x, close parentheses, because now you want to put your entire function squared, comma, x, comma, 0, comma, 2. All right, so let's see what this gives us. Moment of truth. 9.978, so it's 9.978, 3 decimal places, and that's your answer for part C. All right, now part D says the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by this function. So the trick to seeing this is, again, this is kind of three-dimensional. This is your surface area of your pond, and then the pond has some depth to it. Now the depth is changing. That's why it has a weird equation like that. But if you think about it, volume is simply this piece times how deep it goes, right? So if we want the volume of the water in the pond, the volume is equal to depth times the area, right? Each piece times how many you have going up and down this way, that will give you the volume. So that is equal to the depth, which is 3 minus x, right? And then the area that we have up here, this is going to be top minus bottom again. So sine of pi x minus x cubed minus 4x. I'm going to distribute, so minus x cubed plus 4x. So that's the whole thing. Now we have infinitely many of these pieces, so 0 to 2 dx, right? All right. So last time to use our calculator. So math 9. Oh, let's punch this in. It's going to be a long one. All right. So parentheses 3 minus x parentheses sine of pi x minus x cubed plus 4x close parentheses. So that's my two functions multiplying together, comma x, comma 0, comma 2, close, and press enter. And there my pond is going to be 8.36995, so 370 cubic units, right? Really doesn't say what the measurements are, so that would be our final answer. Okay, that's it for number 1.